Hi everyone, this is Sharan here. Welcome to my channel. Today in this video, we are going to see about implementation of a linear regression model. First, we are going to see implementation of a simple linear regression model where we will be having only one independent variable. And then in the second example, we are going to see how to implement linear regression model when there are multiple independent variables, how it looks and how the outputs are produced, how the accuracy of the model is being measured, and finally, we are going to see how it can be implemented for an inbuilt data set. So this will be more of an exercise for you to try out. Before going into the tutorial, if you are interested in learning about data science, please consider subscribing to my channel and enable the notification icon to ensure that all my videos reach you. So now let's move into the tutorial and then see how it can be implemented using Python. So first, we need to import all the packages that is required for us to implement an linear regression model. So here what I'm going to do is I'm going to import the various packages such as NumPy, Pandas, and then I will be making use of a few packages that will be used for making plots, and such as like Matplot library and Seaborn, and I'm also using Polyfit as you see on my screen, which is used to generate a regression line when we are making the plot. So let me import all the packages that is required for today, and I'm going to read the data set. So this is a very small data set, so more like created for the tutorial for you to understand better about how the algorithm works. So let me read the data set and convert that into a data frame. So as you see on my screen, this is how the data would look like. So here we have one independent variable, which is the number of projects, which will be used as an input, and the salary is the column that we will be predicting. So this is the dependent variable. So for this particular data set, let's plot this data plot and then see how the data looks like. So let me use the Seaborn package in order to plot this data plot. So this is how this data plot looks like. So we have the number of projects in the x-axis and the salary on the y-axis. We can see how the data is distributed. We have only 6 data points, so this is just to get a feel about how the algorithm works. So first one is, in order to build a linear regression model, first we need to initialize it. So I'm using red_model variable. I'm initializing the linear regression model, and after initializing the model, so then what we do is when we train the model on the training data set. This can be also called as fitting the model. So linear regression model is part of the supervised learning. So when I say supervised learning, like what it means is we will be supervising the model or algorithm based on a known data set. So here what we do is in supervised algorithms, we pass on the known values, like we know the input as well as the output. We pass on the values, and that will be used for training the model. And once the model is trained, we use the trained model in order to make the prediction for the other unknown data set, like values for which we want to know the predicted salary in this particular case. So let me initialize the linear regression model, and then let me train the model based on the training data set. So now it's all done. So then what I'm going to do is I'm going to check the prediction. So here I'm passing a simple array, and I'm going to convert that into an data frame, and then I'm going to use the model.predict and pass on the values in order to make the prediction. So let me execute this and show you the output. So here, as you see the output here, so these are all the 3 salaries that are predicted for these 3 inputs that we have passed. So when the number of projects is 7, so then the salary predicted is 79.2k approximately. So for these inputs, these are all the outputs that is being predicted. So how the prediction is being made in the linear regression. So if you are not very clear about how the predictions are made, if you can refer to my previous video, which I will provide a link in the description as well as in the top. So if you check there, I would have explained about the concepts involved in it. So the concept involved is the linear regression model makes use of the regression line to make the prediction. So regression line is nothing but the one which demonstrates the relationship between the independent variables as well as the dependent variable. So here in this case we have only one independent variable, so it is we are going to use the regression line to demonstrate relationship between the number of projects as well as the salary. So here the model, what we do is we are going to check what is the intercept, what is the slope, and how the regression line looks like, and then we are going to see we are going to manually calculate all those values using Excel and then validate whether what we get using Python is correct or not. So let me execute this. So this is what the intercept value is, and then the slope value is here, and then I'm going to make use of these two and create a regression line. So as you see here, I have created this regression line based on the formula. So if you are not aware of this formula, you can refer to my previous video where in detail I have explained about how the regression lines are being generated. So now this is the regression line. So what we can do is we are going to use the Excel, and then we are going to check whether the values that we are getting is consistent with the formula that we have used or the formula that we have learned while understanding the linear regression model. So let me show you here in the Excel. So here in the Excel, these two attributes are the actual data set which we used for building the predictive model. So then what we are doing is I'm calculating x minus x bar. So here x bar is the mean value, which is nothing but 16.333, and y bar is the mean value for income, which is present here. So first I'm calculating x minus x bar, and then I'm calculating y minus y bar. So these are all the values, x minus x bar and y minus y bar, and then what I'm doing is I'm multiplying x minus x bar with y minus y bar. The values are stored here, and then x minus x bar the whole square. So as we know, the formula for slope is x minus x bar multiplied by y minus y bar, and the summation of it divided by the summation of x minus x bar the whole square. So what we do is we take the summation of these columns, these records, divided by the summation of these records, and that would become the slope. So if you see here, the slope formula I have implemented as summation of this particular column here, G, divided by the summation of this particular column here. So what the resultant value that we have got is 3028.03. If I show you this particular script here, so you can see that the slope is exactly matching. So similarly, the intercept is also calculated using the formula, and it is consistent with what the model is producing. So this is just to ensure, or just to show you the validation, like how the model works, whether is it correct or not. What you can do is you can also try out the simple example and then mathematically calculate the regression line, the slope as well as the intercept, and then see if it matches with what the model is producing. So this is not practical when we have a real data set, because the number of records will be large, and there will be more number of independent variables. It won't be just one independent variable. So this is just to understand about how the algorithm works. So finally, once the algorithm is built, so then what we do is we understand about how accurate the model we have built is, so which can be calculated using the R-square value. So let me execute this and then show you. So 0.8451, so this is the R-square value. So as we saw in the introduction session, the R-square value of 1 means the model is 100% perfect. So we are able to demonstrate the 100% variance in the particular model. So here in this case it's 0.84, which is still good. We are able to closely predict all those values. And if you are interested in knowing about the mathematics behind the R-square value, you can refer to the introduction session, the previous session, where I have in detail explained about how it works and how the values are calculated. So the formula is 1 minus u by v, where u and v are explained here. Yeah. So as I mentioned, the best value for R-square would be 1, and it can also go on negative. So like ideally the values range between 0 and 1, and mathematically it is possible for R-square value to have a negative value, which means that the prediction that we are making is nowhere close to the pattern that is present in the actual data. So when that is the case, the value of R-square will be in negative. So this is a simple example where we use one independent variable and made the prediction. So moving on to the next example where we are making use or we are using like multiple independent variables. So here in this example, let me clear the output. So I'm going to make use of the same set of packages. So I'm importing all the packages. The only difference is I'm adding some additional variables. So apart from number of projects, I'm adding the years of experience as well as number of courses a particular person has completed, and then I still have this income. So let me read the data set, convert that into an data frame. So this is our input data. We have 3 independent variables and 1 dependent variables. The independent variables are like a standalone variables which is not impacted by any other parameter, whereas the dependent variable is the column that we are going to predict. It is called dependent because we are predicting its values based on the independent value, the independent variables that we pass as an input. So the first one is we initialize the model, same step, and then second we train the model. So here we while training the model, we pass on all the attributes that can be used for training the model, and then we pass on the values that the values of the target column, the column that we are going to make the prediction, so which is the salary. So once the model is trained, so then in this case what I'm doing is I'm going to pass on and sample data and then see how the prediction of the model is. So let me execute and show you this. And so this is the sample data set. I'm converting that into an data frame. So these are the three values, which is nothing but number of projects, years of experience, as well as number of courses completed. And I'm having 2 such data set, and I'm going to pass on this data frame in order to make the prediction. And the model, the prediction can be implemented by using the model variable dot predict, and then we pass on all the values. So if you see here, for these 2 inputs, the output predicted are here. So this is the salary that is predicted for the first input, and then this is the salary that is predicted for the second input. And now we can make use of these functionalities to identify the intercept as well as slope. So since in this model we have 3 independent variables, we have 3 values for slope. So how much ever independent variables we have, we need to have that many number of slopes. So the formula would be, the formula for the regression line would be y is equal to c plus m1 h1 plus m2 h2 plus m3 h3 and so on, where m1 is the slope and h1 would be the variable. So here in this case, h1, h2 and h3 are nothing but number of projects, years of experience, as well as number of courses completed, and y is the salary. So as the number of independent variable increases, the regression line equation also increases, like the number of parameters will keep on added to it, and this can be used for us to get the intercept as well as the slope identified based on the training data set that we have passed on. So that's it about the implementation. So as you see, the implementation as such doesn't change whether it is one independent variable or multiple independent variable. So it's the same steps that is getting involved in it. And the next one is you will be working on a simple example. So here in this case, this is the diabetes data set, which comes with sklearn package. So here we have like about 10 different attributes, and then we will be making use of these attributes in order to predict the progression of diabetes for like different patients. And this is the example, like how the linear regression model is used in order to make the prediction. So you can try it out for this particular example. Like if you need some help, all these scripts will be uploaded in my Git repository. You can download these scripts and then refer to them as well. And that's it for now. If you have learned something new today, please give a thumbs up and subscribe to my channel. And bye for now. See you in the next session. See ya. Bye.